0.013. So which one is our test? It's not equal to 5,710. So this is going to be our testing type, right? Okay, two-tailed test. Therefore, we need to find this value, t sub alpha over 2. Okay, so our testing statistic is this. So you have everything, so I'm going to copy t naught at 0.013. Now I can erase this. And then we need to find this. T sub, alpha is 0.05. So always it is good to have what is alpha over 2? That is 0.025. Okay, so what is T sub alpha over 2? I'm sorry. I have to put this one, T sub 0.025. Okay? So obviously this one is on the right, in this case positive, in this case it's going to be negative. So how do you find this? Go to T distribution table. Yeah, I'm going to standard normal and this P, standard normal, and the T distribution. Yeah, I want to go to degrees of freedom 44. Okay, I want to go to 44. Well, I do not see it. 40 and then they jump to 50. So I'm going to just take 40. Okay, take 40 and then go to 0.025. That gives you 2.021. Yeah, 2.021. Degrees of freedom was 40. Okay, it's simply just as close to 44. That's what that is. Okay, 40. And then you say this is 2.021. So this point is what now? This is 2.021. This is negative 2.021. That's what that is, correct? Okay. So look at this. This is our critical region over here. So if your testing statistics value goes in here, and then we do reject the null hypothesis. But where is this? Negative 0.013, very close to the middle, isn't that right? Very close to 0. So it's going to be around here, negative 0.013. Yeah, this one doesn't fall in the critical region. Therefore, what does that mean? We do not have sufficient evidence to reject all the statistics. Okay? So, what is our conclusion? Our conclusion is we do not reject H naught. Okay? So, in other words, in this case, this young males, okay, just listening to calm classical music doesn't make any difference. That's what it's saying over here. Whether they are listening to calm classical music or rap or, I mean, of course, I don't. It doesn't say anything, but it's a classical calm music does not influence their RMR. That's what that is. Okay, so it's not too bad, right? Okay, so here let's talk about how we are going to find this value. We call this critical value. Okay, we call this critical value. Yes. Or what we need is degrees of freedom, 44. Where is it? So n minus 1 degrees of freedom is 44. And what is the area? Well, this is 0.025, this area. However, okay, when you put it on the calculator, so where to go? Go to second bars and invert t. Go to invert t, and this, when it says area, just let's enter 0.025, and the degrees of freedom is the next line, that is 44. Paste and then enter. That gives you negative 2.015. Why do I get negative? Because I entered 0.025. That's why. In order to get positive answer, positive 2.105, you are going to enter the area 0.975, the other way around, okay, the other part. Then you are going to have a positive answer. But anyhow, you get negative answer, you get negative number over here, the other side is going to be same. So this is a little bit unfortunate case that this is from the book, and we have no choice but using degrees of freedom 40. So this is the answer. On the other hand, if you use a calculator, the calculator generated this critical values over here. Slightly different. However, how much is difference? 2.015. So the difference is 0.006. Okay, 0.006. So that is like a 0.6% of difference. So, well, hopefully it does not affect our conclusion. Okay, if this number is really close to this, it may affect. But in that case, if you have to skip, yes, we use a graphing calculator, whatever that is. Yeah, I assume that this is more accurate. Okay, all right. There is no gap in here. Okay, unlike this table in the book. Okay, so. Oh, by the way, you are thinking, oh, we didn't do something. Well, can you recognize, can I erase this part now? Okay. I didn't do something. That is, in the previous case, we checked a couple of things. One is that n times p times 1 minus p is greater than or equal to 10. This is to guarantee that this is going to be a normal distribution, or approximately normal distribution. But in this case, okay, this one is for sample proportion over here, or population proportion. In this case, what is it? Population mean. Therefore, the central limit theorem says that as long as n is greater than or equal to 30, the sampling distribution is going to be normal. Well, what was the sample size? Here is 45. Okay, so number one, we do not need for mu. Okay, we do not need. This one is only for proportion, because this originally comes from binomial distribution. In this case, where everybody you ask, what, do you agree to banning the cell phone use while driving? Everybody you ask the same question, and the answer is going to be yes or no. Okay, one way or another. But in this case, for population mean, in this case, what is going to be your average utility bill, monthly bill? Or what is on average, how many emails do you receive? Or how many visitors do you have? Or how many customers do you have per day for your store? Okay? So this time you can have 20, you can have 0, you can have all kinds of numbers. Well, you do, and therefore the sample size over here, so it's not binomial probability problems over here. No, not at all. So all you need is this, therefore we don't need that. The another thing is that the sample size has to be less than 5% of this population size, correct? Okay, less than 5%. What guarantees is the independence of those opinions? Okay, here you don't need that. It's not your opinion. Is that right? Okay, simply what? Some just a physical number. Okay, so physical number. So one person's answer is not going to influence the other person. Just by nature. All right. So we don't need this one either. So we do not check. But however, what you need to check is sample size is greater than or equal to 30. Or if sample size is like a 20, like a smaller than 30, in that case, well, the population is already normally distributed. In that case, we inherit that normal distribution throughout those samplings and everything. Okay? Okay, so the next one, the last page over here, example 7. There is a huge sample over here. Example 7. In 2003, the average age of mother at the time of her first childbirth was 25.2 years old, I guess. Okay. To determine if the average age has increased, a random sample of 1,200 mothers is taken and is found to have a sample mean age of 25.5. Okay. With a standard deviation of 4.8, determine whether the mean age has increased during using a significance level of alpha equals 0.05. So let's set up. So what is it saying? The H naught is saying that the mean age is 25.2 when they have the first childbirth. Okay, so this is years. And what is H naught? Has increased. So this is mu is greater than 25.2. Okay? And what is the sample size? N is 1200, therefore n minus 1 is 1199. And over here, x bar is 25.5, and the standard deviation of the sample is 4.8. And the significance level over here is 0.05. Did you summarize everything? Okay? So, what kind of a test type do you need to use? Well, has increased since then, therefore greater than this, therefore you go to the right tail test. Okay? So alpha is going to be this. So let's determine this T sub alpha precisely. So T sub alpha means T sub 0.05. Correct? And of course the degrees of freedom comes first, 1199. Do you think you can find in the book? Yeah, in the book, 1000 and then go to infinity. So 1000, so I'm going to use just 1000. Use degrees of freedom, 1000. And that is go to 0.05. 1.646. Okay, 1.646. This is T sub 0.05 is 1.646 by book. that is unfortunate. Okay. If you use infinity, so is there any much of a difference? Well, by book, so did use this. So use df is infinity. Hey, what is this? Not much of a difference at all. 1.645. So again, the difference is going to be 0.001. Okay, so, well, not much of a difference. Okay. Oh, I didn't check with the calculator. I forgot that. Okay, so second verse, go to number 3 option. I'm sorry, number 4. Invert t. So this time the area is 0.05. That is 1199. See if the calculator accepts that. Oh, negative 1.616. Again, I use the number 0.05. That's why this number they gave you. The calculator gives you negative 1.646. Therefore, this one has to be 1.646. So this time by book, okay, by book using what df is 1000, or on the calculator I put exactly 1199 and it gives the same thing. So by calculator, same number. Okay, so here we go. We have this number. So what is our testing statistic? So let's compute T naught. What is T naught? What is X bar? Yes, 25.5 minus, X bar minus mu naught. Whereas what is mu naught? Yes, mu used in H naught. So that is 25.2. And what is S? I'm sorry, not S bar, S 4.8 over square root of N, 1200. Okay. Do you notice that once you subtract, this is a very small decimal, 0.3. This is a small number, but this 1200 is a relatively large number. Isn't that right? Okay. Alright, so once you compute that, this is going to be still positive. That gives you 2.17. So why does it become big? Because this one you have only 0.03. Because this one goes to the top. You know what I mean? When you have a 1 over 1/5, what do you see? This is 1 divided by 1/5, so therefore 1 times 5, that gives you 5. So the big number in the denominator of this denominator, okay? The big number in the denominator of this whole thing denominator will make this quotient large. So that's why you have a relative, unexpectedly, honestly for me, kind of 2.16 surprised me a little bit, okay? But I see the reason why. Because the denominator, the bottom number is so big, that's why. Okay, so at any rate, our thing is 2.17. So 2.17 is located over here, 2.17. This is our testing statistic. This falls in what? Critical region. Therefore what? Therefore, this is greater than 1.646. Therefore, we are going to, it's time to change, basically. Okay, time to change. So what is our conclusion? Is that we reject H naught. So we say just this is the end of the story in terms of this, but of course in my mind, in our minds, that we reject that, so we agreed that well, the first child birth age has increased, okay, has increased. So what is evidence? Our evidence is 25.5. So let's talk about this. Yes, when we reject the H naught, this 25.5 is what? Statistically significant. Significant that we do reject our old norm. Okay? So be it. Okay, test is done. By the way, as soon as you use period over here, test is done. But let's think about really what is going on here. What is going on? So, just this is a case like when they say it's like, this is just some classroom example. Well, you see, yes, we say this is statistically significant that we are going to reject our old norm, so H naught. But then, practically, is it so? I mean, the first childbirth age is 25.2 versus 25.5. Is it a big deal? If it is like 18, we have some message over here, message to send to young women. Imagine if you have a baby over here, then do you think you can pursue your college degree? I mean, you can do that, okay? I'm not saying it's impossible. However, well, it is going to be very difficult, a lot more difficult than now, correct? Okay? So, or any other, I mean, this is going to be the progress of their life goals or, their dreams. It can be hindered for a while, okay? So that is important for the adult to send a message that, hey, can you slow down so that can you postpone, okay, your childbirth. Or if it goes to mu equals like 31, and then there is another message can come out like, hey, you want a healthy offspring? Well, the earlier the better. When your body is younger, you probably were more likely to have your healthier child over here, okay? Which is true. In that case, yeah. So there is nothing like that. You know what I mean? If there is a drastic change, then we can have some kind of a campaign, or we can have a kind of a healthcare reform that to accommodate the new trend, things like this. But not a big deal, 25.2 versus 25.5. So this is what the book says about statistical versus practical significance. Yeah, it was a statistical significance over here, okay? However, practically, it's not that significant. It's like a 30% of chance of rain today versus a 40% of chance today. Am I going to go and get the umbrella because of a 30 versus 40? Maybe not. If 30 versus 80%, yeah, I'm going to, okay, I need an umbrella, I'm going to go and get it. Yes, so that is that. Okay, so whatever you have over here, to go through these problems, that you must feel comfortable with this graphing calculator when you use a second verse or when you use STAT and test. STAT and test are for the interval, confidence intervals, or this testing stuff. The most things are